Hello. Today we're going to 5, 4, 3, 2, 1. Hello. Today we're going to be starting the next unit, Energy, Resources, and Consumption. Here we're going to be covering topic 6.1, Renewable and Non-Renewable Energy Sources, and 6.2, Global Energy Consumption. For 6.1, the objectives are to be able to identify the differences between non-renewable and renewable by graphing, by charts, by concept, by written word. For example, difference between renewable and non-renewable. Renewable means it can be replenished naturally at or near the rate of consumption. There are, however, depletable renewables that can run out if overused. For example, wood, charcoal, ethanol. Non-depletable ones would be like solar, wind, geothermal, hydroelectric and geothermal, where basically there's no way we're going to run out of the sun or run out of the wind because that's dependent on the sun. Non-renewable means they exist in a fixed amounts that in a lifetime cannot be regenerated. For example, fossil fuels. There remains of biomass that were around hundreds of millions years ago, either in organisms that were animals or in plants that died. Nuclear is another one that can be generated from uranium, plutonium, or other radioactive fuels that cannot be replaced. For example, in petroleum, there are organisms that died 300 to 400 million years ago, either in the oceans or plant life on land. And they were buried under sand, silt, soil. And through millions and millions of years, the temperature got hotter, the pressure got hotter, and it went from being organisms to basically just carbon and other basic molecules. And what we had to do now is we had to drill down through sand, silt, and rock to get to the oil, gas, natural gas resources. So the rate of consumption must be at or below the rate of regeneration for renewables. Here we can see that for trees, the deforestation, the darker color, has been very, very high from 1966 on. And the amount of reforestation is not even close to that. Are we going to run out of them? Well, let's see what happened in the Amazon last summer. Fossil fuels will run out because they take hundreds of millions of years to regenerate, as opposed to be less than a human lifespan. Here we can see that oil and natural gas have around 50 to 53 years before they're all gone. Coal, on the other hand, has up to 114 years, but we'll find out later how much nastier it is. So the first practice FRQ would be, can you explain whether or not biomass is renewable? Second of all, can you justify your answer? Hopefully that was helpful. Section 6, topic 6.2, global energy consumption. Here we're going to be asked to describe trends in energy consumption and do some calculations. So developed versus developing countries. Developed country nation uses more energy on a per capita or per person basis. But developed countries are using more energy in total. Why? Because they have a lot more people. We can see here on a per person basis, the United States and Canada are number one. And in the United States, we use up to 5 times what the rest of the world uses. Developed countries are still industrialization, population is still growing rapidly, and this will increase on a per person basis as their economies industrialize and they achieve higher standards of living. So we can see here from 1950 up to today, the more developed countries have basically not increased in the amount of energy per person, whereas the developing countries have gone way, way up in the amount they use. Why? Because the amount of people. Fossil fuels are the most used energy sources. Why? If we can see here, oil, coal, and natural gas are much, much higher than hydroelectric, nuclear, wind, and solar. Why? Oil is used in gasoline. It's a main fuel for vehicles. Coal is used for electricity. Natural gas is starting to outpace those two, being used for not only vehicles, but for electricity. Main thing it's been used in the recent past is for heating. Hydroelectric dams are the second largest source, and what they do is the water behind the dam has a lot of potential energy. As they go down the chute, potential is converted to kinetic, hits the turbine, spins it, and that kinetic energy is used and transformed into electrical energy. Nuclear is the third largest source, and what happens there is uranium fission, not explosion, but fission, controlled fission, boils water into steam. That steam turns a turbine, which that kinetic energy of the spinning is converted into electrical energy. So development increases the fossil fuel consumptions. Many residents of less developed nations depend on substance like biomass. So we can see here, back around 200 years ago, most people just used biomass. That's it. Then we started using more and more fossil fuels. That's actually going down. Natural gas has gone up. Hydroelectric has been changing, and so forth. And so the consumption sources are changing. If you're a less developed country, you're more likely to use wood, charcoal, like we used in the United States 100 years ago, 200 years ago. But this can lead to deforestation. As we develop countries, we increase our affluenza, our wealth, which means more money per person, and therefore we use more energy use. You can see here on a wealth per person, as we go from 1,000 to 10,000 to 100,000, the amount of fuel we use goes up. The amount of energy per person goes up. If you go from Niger way down here, all the way to Qatar, there's a huge, and what you need to notice is this is a logarithmic. So this is 10 times as much as here, both on the vertical axis and the horizontal axis. So it actually is much more than what it appears to be. As developing countries develop, fossil fuel consumption will increase. Why? They start getting vehicles and they need oil for the vehicles. They need electricity, and they need coal and natural gas. Electricity demand for homes and businesses will increase as they become more higher wealth. Factors that affect it: availability. If there's too much fossil fuels, the price will go down. If there's not enough, the price will go up. Here we can see the amount of natural gas production has gone up greatly, oftentimes because of fracking. And as the amount of natural gas goes up, the price of it goes down. However, like I said, fracking has opened new reserves, making the price actually go down. And you can see here that the prices have gone down because of deposits opening up in Oklahoma, Pennsylvania, and the like. Government can affect the price, but we can mandate certain energy source mixes. For example, say that there has to be a certain amount of the mix of liquids within gasoline. It has to be octane, it has to be the highest amount in there. However, they cannot say you have to have a certain price, for example, $10 per gallon. What they can do is discourage companies from building power plants by increasing the taxes. It's called a carbon tax. They can also do that for gasoline, cause a carbon tax there to discourage use of gasoline. Or they can cause rebates or tax credits to encourage companies to use renewable or people to use renewable energy. We can see here there's various places around the world that uses renewable energy sources. For example, right up here in Copenhagen, Denmark, huge amount of wind power being used. If we look in the United States, 77% of the electricity is done by renewables, water in Idaho and Washington. More and more electricity and geothermal is being done in California. Over here in either Vermont or New Hampshire, I'm not sure which, 99.8% of their energy comes from renewables. So a practice FRQ for units topic 6.2. From 2005 to 2018, the annual investment in renewable energies in the U.S. increased from 11.4 to $46.5 billion. Can you calculate the percent change in renewable energy investments in the United States? Make sure that you indicate whether it's increase or decrease. Second, can experts estimate that for the United States to reach 100% renewable by 2050, it would cost $7.8 trillion? Can you calculate the percent change this would represent from the 2018 investment level of $46.5 billion? Hopefully this was helpful. Thank you.